This problem is asking to evaluate the CP value of CO2 at different temperatures and constant pressures by calculating the partial derivative of enthalpy with respect to temperature, which is this formula right here. So we're going to use the IG model in test calcs. So test calcs, system state, since there's no flow, IG model. And then we can start entering our values. So it's CO2, so we'll change that in the upper right corner. And P1, we're just going to assume is 100 kPa. And then it says T1 is 300 K. Alright, calculate, and then we have our H value right over on the top right corner. So the next state, the pressure is constant, so just equals P1. And then since it's a partial derivative, dH over dt, that means over a really small increment of temperature. So we'll want to do something like equals T1 plus 1 Kelvin. That will give us more accurate results than if it were a higher temperature. So now we hit calculate, and we have the H value for state 2. And now we can go to the I/O panel and calculate CP. I just arbitrarily chose CP as the variable name. You could choose anything you want. And then since it's dH/dt, it'll just be the change in enthalpy over the change in temperature. So divided by T2 minus T1. Oops. T2 minus T1. Alright, and then hit calculate, and we get CP equals 0.846. Note that in the state panel, in state 2 and state 1, it actually calculated CP for you and gives very similar answers. So the next part of the question is asking, what if the temperature was 3000 Kelvin? Since T2 is based on T1, T1 is the only value we need to change. So we'll change that to 2000 Kelvin. And hit calculate. State 2, hit calculate. We also could have just hit super calculate for both of those. And it would bring us directly to the I/O panel. And we'll hit calculate again for this. And it gives us a CP value for the 2000 Kelvin of 1.37 kilojoules per kilogram Kelvin. And again, we can go check that in the state panel. There it is, 1.371 and 1.371. And the next part asks, what would it be at 4000 Kelvin? So same thing. State 1, we're going to change it to 4000 Kelvin. Can hit super calculate. And that brings us back to the I/O panel where we'll hit calculate again. And so for 4000 Kelvin, we get a CP value of 1.437. We can check that in the state panel, 1.437 and 1.437. Looks good. The last part of the problem asks, what would the answer be if the pressure increased to 1000 kPa for 2000 Kelvin? So similar to last time, we'll just change T1 to 2000 Kelvin. And this time we'll change P1 to 1000 kPa. And hit calculate, and state 2, P2 is equal to P1, so we don't have to change anything. And T2 is based on T1, so we don't have to change anything. So just super calculate. And then we just hit calculate here, and we get 1.371, which is what we got before at 100 kPa, because pressure really doesn't make any significant difference in the CP value.